Welcome to ECE 761, lecture number 8, Robot Programming. The goal of this lecture is to illustrate some of the typical programs that you would write for a robot to get it to draw out a certain path. So far we've got forward kinematics, that's given the joint angles, find the tip position. We've got inverse kinematics, given the tip position, find the joint angles. We've got spline curve fitting, how to go from point A to point B. With that, I want to write a program to specify a certain shape. Now to do that, a couple of routines would be useful. Move to command would just say, give me points every 0.01 second to go from point 0 to point 1, using your favorite spline interpolation. I'll be using cosine interpolation. Draw a circle. Draw a circle starting from point 0, P0, centered at point PC in t seconds. Draw an arc from point 0 to point 0 through point 1 to point 2. That'd be the second one down here in t seconds. I'll first describe how those routines work, and then we'll use them to draw a dogwood flower. The first one is move to. I want to go from point A to point B in t seconds. So that'd be the Matlab subroutine. I'm basically doing a linear, or actually cosine interpolation between those 2 points. What that looks like is this. We go from point 1 to point 2 in 3 seconds. It's a little bit slow, but that's the cosine interpolation. I start with 0 velocity, pick up speed in the middle, and then at the end I come to a stop. That's the move to command. Since I'm using cosine interpolation, these are the joint angles as I went from point A to point B. I can also use that to draw a box. For example, to draw a box, I'll specify the points of the box. Here's the first move to command. And that was way too slow, so I'm going to speed it up some. I'll go from the first point in 1 second. Then the second one to point 3 in 1 second. Go to point 4 in 1 second. And then back to my starting point. So the move to command lets you draw straight lines. It's straight lines in the tip position. The joint angles will be nonlinear, of course, due to all the sines and cosines. What you really care about for the robot, though, is the tip position. So there's the angles versus time. The next program instruction is circle. I'm going to specify the starting point, the center of the circle, and how long it takes to draw it. So now if I tell it draw a circle, starting at point 10, 20, 0, the center is at 30, 30, 0, and draw it in 2 seconds. Again, I'm using cosine interpolation, so the starting velocity and ending velocity will be 0. But the tip then traces at a 0. The final program is an arc. I want to draw an arc between point 1 to point 3, passing through point 2. And this gets a little bit tricky. There's going to be a circle that connects all 3 of those points. Find the center of that circle. So doing some algebra, multiplying it out, simplifying, I eventually wind up with 2 equations, 2 unknowns, and you find the radius. Once I find the radius, I know the angles to go from point A to point B, do interpolation for those angles. Once you get that working, that's the program arc xy. I'm going to go from point 50, 0, 0 to point 40, 40, 0. We're passing through point 40, 40, 0 to point 0, 50, 0 in 2 seconds. So we now have 3 instructions. Move to, draw a straight line, draw a circle, and draw an arc. Now comes the fun part. Let's write a program to draw a certain shape. Here we're going to draw a dogwood flower. So what I'm going to do is I'm going to start right here, come down to the page, draw out a circle, then an arc, another circle, arc, 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 and then done. To do that, I'll specify the points. That's these guys here. I'll then do a bunch of move to commands, circles and arcs. And then when I'm done, the angles are basically your program. That specifies where the robot's supposed to be at each time. So the first one is come down to the page, then draw a square. This takes a while. But if you trust me, eventually when you're all done, it draws out a dogwood. The resulting joint angles are basically your program. Since I'm using cosine interpolation, these are all continuous. The velocity is 0 at each of the points. Take this first derivative, take the second derivative. The second derivative will also be finite. So this would be a valid program, valid specification of joint angles that draws out a dogwood flower. The homework for number 8 is a 2-day assignment. Here it's pick a shape. Basically pick your favorite. Some people did a Batman symbol, some people did a Verizon symbol, or different shapes. Specify the points using move to, arc, and circle commands. Write a program to implement that shape. What you're looking for are the resulting joint angles. Give me a plot of the resulting joint angles, and you got homework set number 8 finished. Just make sure that the second derivative is finite, because otherwise you can't implement it. That's number 8, programming for 761 Robotics.